pilot sought to understand. This pilot sought to understand how cover crop and no-till practices impacted whether a field was declared preventive plant in 2019. This research has resulted in some very important findings, which we are excited to share with you today. To get us started, I want to welcome Bill Northey. Bill currently serves as the Chief Executive Officer of the Agribusiness Association of Iowa, and was very instrumental in his role as the former USDA Undersecretary for Farm Production and Conservation. And he's going to kick off our conversation first. But I'd like to introduce our two researchers who are well-known experts in their fields. Dr. Bruce Sherrick, who led the research effort, serves as the director of the TIAA Center for Farmland Research at the University of Illinois at Urbana-Champaign. And Dr. Rob Myers, who serves as the director for the Center of Regenerative Agriculture at the University of Missouri. He provided expertise on cover crop and no-till, reduced-till management, and the overall agronomic considerations in conducting the pilot. So now I'd like to turn the floor over to Bill to set the stage for us. Over to you, Bill.
Very good. Well, thank you, Deb. Glad to join the call and look forward to the conversation as well. And just got my own chance to look at the report and understand some of the results, and looking forward to hearing from Bruce and Rob about that. So as you said, I was at USDA as we put the pieces together of what a study would look like. But my life prior to that, I go all the way back to the farm in Northwest Iowa. And so farmed for just under 40 years. And until I went to USDA, was active in National Corn Growers, served as president back in the 90s, and then was Secretary of Ag in Iowa. Lots of policy discussions, a great appreciation for crop insurance, and the great information that's there. A real proponent, too, of conservation practices, and how I believe many conservation practices can be helpful to the producer, to water quality, but also probably impact in a positive way the reduction of risk of growing crops. And I was a no-tiller and cover cropper myself. It's really hard to measure that. Once I got to USDA, there's an awful lot of data there, but a really primary concern for USDA is a section called 1619. And we talked an awful lot about that. Farmers' data is private, and you are not to be sharing that private data, so that when a farmer comes in and shares their acreage report or their yield information, that is information that should remain theirs and not open to the public. But was there a way to connect that data in a way that could be protected to the conservation data, to be able to figure out, could there be some of those positive benefits to the producer and the production, and especially the risk to crop insurance by some of those practices? And so that was the conversation. It was really kind of started with some lines in the 2018 Farm Bill that asked for some data analysis that could be done while still maintaining that confidentiality. And then we spent months and months, didn't we, Deb? Months and months going through the process of figuring out what would confidentiality look like, what would make our folks at USDA, NRCS, and Risk Management Agency, and USDA at large, as well as FSA, what would make them comfortable with what that data management would be. And we finally got to a place where we were comfortable enough to call it a pilot and do an effort. And that's what this is. So that's how we got to this point. Is it did take that data, and Bruce and Rob will tell us a lot more about all that, but it did take that data, pull it together in a way that there could be some comparisons and look at the tendencies. Think of this: you got millions of farms out there. And no one farm tells you everything. In fact, no 100 farms tells you everything. But when you do lots of different farms in lots of different places, could you figure out that there might be a reduction in prevent plant from being able to have, or by having cover crops and no-till. Likely remember 2019, terrible prevent plant year. We had a lot of the country had some real problems. And so it became a really great case study to be able to say, is this a time where we could see a positive impact for the producer and for crop insurance risk by being able to have cover crops and no-tills on land. So Bruce and Rob will kind of walk us through that, but that's my stage setter, Deb. And I'm sure looking forward to the conversation.
Thank you, Bill. I really appreciate your perspective and your support. And we look forward to hearing what's next for data, what's next for conservation and research. Now I'd like to turn it over to our research team that was led by Bruce, but I'm going to let Rob and Bruce take you through the findings and recommendations. So over to you, Rob.
Sounds great. Thanks, Deb. And thanks, Bill, for that introduction, and especially for helping make this project possible. So the two of them have laid some great groundwork for how this project came about. I first want to give nearly all the credit to Dr. Bruce Sherrick, who will speak after me, for leading the data analysis effort. In the context of the privacy comments that Bill was mentioning, all the data stayed in the hands of the University of Illinois team. Bruce could describe the details for you later, but the identifiers were stripped out immediately, so we never saw that. In fact, I never saw the raw data at all. I only saw the summary analysis, which was the plan from the beginning to closely protect that data and be sure to maintain privacy. Having said that, we thought that this was a unique opportunity to look at what happened in 2019. As Deb said, we had very unusual weather that year with the 19 million acres not be able to be planted. And that's several times what we would see in a normal year. I first started to see some data on the impacts of these conservation practices in tough weather years in 2012, when we had a major drought and we had farmer survey data showing us that cover crops helped farmer yields in that drought year. So we had the opposite situation in 2019 with an extremely wet spring, and Dr. Sherrick will go more into depth on the unique pattern of the weather that year. But without question, it created a lot of hardship for farmers, both in greatly delayed planting. For example, on my own family farm in central Illinois, the corn was not planted until the second week of June, almost 2 months after would normally be planting, or not being able to plant at all. As Deb said, 19 million acres not planted at all, and filed for prevent plant crop insurance. So the acreage that had these challenges was widely scattered due to the broad excessive rainfall that occurred that year. But about half of that acreage was in 6 states: Illinois, Iowa, Indiana, Minnesota, Missouri, and South Dakota, as Deb mentioned earlier. So what we wanted to do in this pilot is to see what USDA data could tell us in combination with complementary data from the private sector about the management impacts created specifically through cover crops and no-till on risks that farmers experienced that year in that wet weather year, just as, again, a pilot effort to kind of see how all this data fits together. And we had efforts to work with the Risk Management Agency, the Farm Service Agency, and Natural Resources Conservation Service. We're very appreciative of the staff and those agencies for working with us to identify the relevant data that they had. Now, we all knew going into this, both USDA staff and those of us working on the pilot, that not all the data that we would ideally like would be available. It's just due to the limitations in funding and the way the data is collected. But we also thought that this pilot effort would give us a chance to see how we could improve the data system going forward in the future, which is a goal everyone shares, I know. We had 2 particular questions we addressed through the data, and I'm going to show you the results here in a moment. One was, did the use of cover crops and no-till impact the likelihood of prevent plant insurance claims on corn and soybeans? So we focused on those 2 crops in 2019. And then secondly, for the fields that were able to be planted, how did the planting date get impacted? So let's look first at the prevent plant insurance claims. So again, 19 million acres had claims filed on them, about 10 million acres in this pilot area. What we found by looking at thousands of fields, and again, I credit Dr. Sherrick's team for crunching the numbers on this, was that at the average loss rate in 2019 across those 6 states, the use of no-till and cover crops reduced the odds ratio of prevent plant insurance claims by 24%. Now that's kind of a mouthful to go through, a little bit unique explanation, but it fits with the crop insurance pattern in that there could be a higher or lower likelihood of a claim being filed in a particular area. And so Dr. Sherrick and his team felt that this was the best way to frame up the results, and he can talk about that in a little more depth. We do want to note that there were other things that contributed to the prevent plant claims happening, as you would expect. Obviously, the number one thing was all the rainfall that happened, but also the slope of the soil, the water holding capacity of the soil, other topographic features, and so on. So this is just an example to kind of give us a more visual depiction of what was going on that year. This was a field from Oklahoma that spring, provided by a farmer named Russ Jackson. And Russ farms on the left side of this image, a long time no-tiller and been using cover crops for several years. There's the same soil type, as I understand it, on both sides of the road. The field to the right is a conventionally managed field with normal tillage and no use of cover crops. Now, this is just one example. There could be lots of other examples we could look at, but it's just the one to show you that at least in some cases, we were hearing evidence, anecdotes, I guess you could say, that farmers with no-till and cover crops were finding their soils were draining better and they were able to get in the field earlier. So we really wanted to look at that on a large scale. As Bill Northey said, you can't just look at a few fields. We wanted to really look at thousands of fields in this case to look at the pattern. So we saw, as I mentioned earlier, this positive impact on whether insurance claims were made, but we also wanted to look at the fields that were planted. And it was quite interesting. If we looked at the data as a whole, these thousands of fields, on average, there wasn't a huge difference from cover crops and no-till, but when we really looked into the data in more depth, we saw this interesting pattern, which was that for both soybeans in the lower right and corn on the lower left, the pattern was similar. And we've got lines here representing blue that had cover crops, orange that had just no-till, or green that had both. Early in the planting season, like in April, the farmers were planting their corn and soybeans later when they had the use of those conservation practices. Now, why is that? Well, if it was just no-till, it could be a couple of things. Those soils might have been a little cooler and wetter. If it was cover crops, what we often hear, and in fact, I was just at a cover crop conference a couple of weeks ago, and a lot of the farmers were saying this, that they purposely delay their planting somewhat so that they get more growth out of that cover crop and more benefits for the soil health. But what was really interesting and what we wanted to focus on was what happened late in the spring. As we got into the latter part of the spring, we found that at that point, the cover crops and no-till really started to make a positive difference. And the reason that is so important is that is the critical time for determining the yield. If we have a week or two delay in April, maybe even intentionally, it really doesn't impact yield in most years. It can in some years in some locations. But as we get later in the spring, that's when it's really important to get the crop planted on a timely basis. And as I said, that year, farmers, many of them on millions of acres, were planting weeks and weeks later than normal. So this was a significant finding. It's specific to this year, but I expect we'd see something similar in some other years. So just to explain this a little bit more, and then I'll turn it over to Dr. Sherrick to talk about the data some more. If we look at a field, let's say we have a cover crop field on the left that has not been tilled, and a field on the right that has been a conventional field with tillage, we would see a very different pattern in the vertical profile of that soil. First of all, we're going to get earthworm tunnels from things like night crawlers that are tunneling vertically. And we also get roots decaying from the cover crops as well as the cash crops. And both of those create channels for rainfall to soak more rapidly into the soil. as opposed to distributed soil that's been tilled like we see on the right. The other thing is we have more water holding capacity. You can maybe see there's more of a blocky appearance to the soil on the left. That's because it has more aggregates created by the extra glues from mycorrhizal fungi and the extra organic matter in the soil. So that creates more water holding capacity, all of which contributes to less standing water on the surface. Another way to visualize this, many of you watching this webinar have probably seen a rainfall simulator. Many of these are out around the country to kind of demonstrate what happens in different field situations. So in the middle here, we have cover crops. You see the green area growing, and then next to it is obviously a bare soil, in this case, a loose tilled soil. The people doing these demonstrations will take a spade and slice the soil about 2 inches deep, and then they're put into these pans that have holes in the bottom. And if the rain is running off the surface, it'll go into the front jar, like you see with the tilled soil. Whereas in the cover crop, there is almost no water in that front jar. Instead, the water is percolating into the back jar because it's soaking through due to those macropores from the earthworms and roots. Another way to see that is to take that pan of soil and flip it over. So here in the front is the soil that has been tilled, and what happens is the rain is sealing that soil shut. It's just not soaking through into the soil depth very easily, whereas the soil in the back that had the cover crops and no-till is soaking in quite readily. So these are just some illustrations of why you might see standing water in a field that has been conventionally managed and take longer to get into that field in some cases. Obviously, there's lots of different circumstances that happen. So with that, I'm going to turn it over to Dr. Sherrick to talk more about the data from the project. Bruce.
Thanks, Rob. I'm going to start with a bit of a technical presentation just to give a sense of how we proceeded through the data, how we were able to treat the data, and how we were able to come to some conclusion, controlling for some of the particularly significant issues in looking at 2019, which was by all accounts a fairly anomalous year. This first slide is just simply to show the location of what we could consider to be cover crop as one of the example layers we used. There was a question that came in the chat that said, what form of cover crop did we use? We did quite an extensive set of approaches, both recorded data from FSA and NRCS, visual data, satellite processed images from multiple sources. And the technical report has a bit more detail in it, but I wanted to impress upon kind of the viewers of this, the sparsity in a sense, but yet the number of dots. We had, Rob has said thousands and thousands of fields. We actually had millions and millions of observations. Given the way we had the starting point, we had to be able to find ways of controlling for the dissimilar use of cover crops, both through time and by location, along with, if Rob, you'll go to the next slide, along with the fact that the definition of anomalous weather is actually fairly complicated. The first picture here, we just took PRISM data. We're able to create reasonably smaller scaled versions of them and then collate through time so that we could talk about the weather-related effects, growing degree days, temperature, evapotranspiration, and create slope pressure index numbers at a location based on how much rainfall landed and could get away, convergence measures, so how much ponding and puddling potential there was based on the topography of the particular field. And again, this is a complicated thing when you get all the way down to field level analysis. It's a scale of a problem that's a little complicated to describe. But if you kind of start with this one, this is just April, when you would think of the planting having begun in the lower part of the Corn Belt. And of course, another complexity is that the planting date proceeds through time, generally from south to north. And so the definition of the planting window relative to the expected planting window also changed. Aggregating through time, just one of the measures, there's just hundreds and hundreds of ways of thinking through this, but one of the measures that I think summarizes really nicely, because it corresponds very closely with where the prevented plant claims were, is to look at this aggregated precipitation amount from March through May in 2019. And if you focus on that kind of corner or intersection between South Dakota Minnesota and northwest Iowa, you kind of see the place where the bulk of the rain in the heart of that particular corresponding planting window really occurred. The areas in through northern Missouri and through Illinois likewise were an incredibly wet and heavy period of time. So again, as Rob indicated, some of the findings that our longer report will have much more detail in it, of course, but was that cover crops and no-till together in particular allowed for a better management of planting date. Wouldn't say that, faster planting is always better or that delayed planting is always worse. But when you got to the prevent plant date, which also changed by location through the latitudes, we were able to match this up really well. Rob, if you go to the next one, just to say also then at the field level, these are like oversized dots so that they show up, but each dot is one field or one CLU in this case, about an high 80% correspondence between CLUs at the unit level of insurance, at least. We could identify a unique CLU with a claim, I should say. This shows the number of total claims, not just prevented plant, but all of the items out of RMA's loss database that in 2019 had a claim of some form. So that's more than just prevented plant, but we could isolate the ones that were due to prevented plant. Importantly, also, the use of cover crops differs following corn or soybeans, right? So the typical practice is not that you always use or never use, but you may have a particular rotational pattern that requires every other year a real cover crop and occasionally use of winter wheat, for example, in some of the regions depicted here. And so we also went back through 11 years of crop data layer information and assigned rotational patterns. And for something that was fairly unambiguous, corn, soy, corn, soy, corn, soy, corn, soy, for example, we can, based on the number of observations, you can create a confidence interval around the likelihood of the next planting being either corn or soybeans. We assigned that to each field too, so that we could control for the incidence of prevent plant corn that might have been expected to have been a soybean field, and hence would have had a different pattern of preceding cover crop usage. I think that's an important detail. Again, these are all very technical. As I said, I just want to walk through the approach so that the seriousness with which we control for elements that might be confusing when you get down to this scale of data would be a little bit more apparent. Rob, you want to go on to the next slide? And then we could look at a bunch of things, essentially where nothing ever was planted, where something did become corn, where something wasn't ever planted to corn, but ended up soybeans, because in 2019, we allowed a provision of cover crop usage of soybeans in certain areas after prevent plant. And we could follow through and assign to each of the specific individual CLUs or parcels. We're using some labels here that are a little bit less technical than they need to be for a final report. We created a boundary layer that was essentially equal to the 2019 CLUs from FSA, so that we had a standardization of the perimeter fields. That turns out to be an incredibly vexing problem as well. But we again could control for what actually happened in the year. And Rob, if you'd go on one more. And then could also look at the planting dates that both actually happened and what we would have expected under normal weather. A punchline that I'll preview is that we had such incredibly strong water pressure in an area that had some higher propensity for claim anyhow, that it's a little bit like saying, how strong of a tent do you have to withstand a hurricane? So one of the really important takeaways here is that the areas that had just such incredible flooding, to some degree, you wouldn't have expected to find any difference because the pressure was so incredibly great. It turns out to be something we can tease out of the data because of the other controls we had, to be able to say controlling for the fact that cover crops were used and we could match them up in close proximity to a place with similar soils, similar planting date, and a cover crop was not used at a field by field level basis. And again, I see some of the names on the attendee list. There's some folks who've done some great work in this area. It's a really complicated problem though. And so we did what we could to match and control for each of those features, including the temporal component of this. and found the most remarkable thing that even with these strange effects, we could deduce marginal effects that are very, very significant. A couple of other observations. We find out, it's a phrase I've sort of become fond of. We find out that farmers are, again, the smartest people in the room. The use of cover crops, if we go back through time and associate it with the topological features and the soil features, cover crops have been used in areas where they have the greatest effect first. And this is important for policy design because a simple one-size-fit-all may or may not be the right way to induce additional cover crop usage if that's your goal in the first place. But we can find places where the use relative to the potential benefit has different economic relative magnitudes. Also, the different states represented here represent some great natural experiments in when programs were designed to induce people or encourage them to adopt cover crops, $5 payment against crop insurance. And Bill's been being a little bit humble in his introduction of himself. He's kind of a thought leader and a real leader in terms of getting some of these programs up and running and started. And you can see in the data, we can find incidents of sort of quantum changes in reported amounts of cover crops. Farmers likewise don't necessarily report uniformly. We'll get into the recommendations in a minute as well. And then the definition of a cover crop is not a single one thing. So we ended up, as we'll talk about in a bit, being able to augment the data with some satellite data where we could identify to some degree the effectiveness of cover crop. Again, somewhat categorical, I get it, but if you said you planted a cover crop but it never emerged, was that a cover crop? Or if you had a failure to kill henbit, is that a cover crop? And so there are some real live on the ground agronomic issues that are important to get right rather than to take surveyed target responses as the truth, because you end up with a bunch of observations on the other side that don't match. And again, I realize I'm getting a bit long-winded on the technical details, so move on to the next slide, and we'll just talk about some other things that along the way we discovered. The pilot project was designed around 3 specific questions, and we learned a lot in doing this about how to design this project, perhaps for going forward purposes. And again, the recommendations will have, in some sense, address the primary ones, but we also found a lot of other things around the impact of the topological features and the soil features and the rotations prior that actually impact risk as well. We also found out from areas that were not affected as much by the flood, why by state the results might differ. And instead of by state, one could think about it as being the intersection between soils and production practices and weather. And because crop insurance does have some geographic perimeter weights at the county level in simple circles, you do end up with some effects that have geopolitical boundaries as well. But we learned about that and what would be the right way to approach representing those features if one has a policy that was designed to rate crop insurance accurately or encourage cover crop usage where it has the greatest benefit, or to reflect places to cost share where the outcomes have the greatest chance for influence. We also were able to look at some things not using just the data we got, but within this context to say things like, would there be a yield effect? It turns out that one of the major features is it's actually hard to figure out when something happened in some of the data sets. And the yield from RMA's perspective is essentially reported in an after the fact case, which ends up in the next year's data. Rob, are there any other observations you wanted to add in at this point, or should we move on to the?
I think we could go ahead to the recommendations
Okay.
section, and I know you wanted to start with the
Sure.
example of the common land units.
Right. So the data came in as was identified earlier, but I'll put a little slightly finer point on it. We received the data in a fairly encrypted form, installed it on a standalone server not exposed to a network, stripped out anything that was PII before even touching any of the other data, and then kept an entirely separate anonymized data set only for use within the project. When we were done, we packaged all that up, put a double key system on it and shipped a copy back to USDA so that if people wanted to pick this up and open it up and go forward, both sides, our side and USDA, would both have to agree to unlock the project data. And then you would be able to only at that point begin to, under the same protocols, essentially with anonymized data, add extra years observations into it without recreating from scratch. And there's just hundreds of thousands of dollars of compute time alone in getting to this point. So it doesn't make sense to us to start over. It did make sense to us to destroy all the data, but ship back a copy that is in a double vault. And those in the technical side, it's a really amazing double vault. But just identifying where something happened. This is just to point out the complexity. This is a depiction of a CLU, an actual CLU, and clearly subfield A is really just pasture and subfield B extends beyond the perimeter of this particular CLU. And so the correspondence of fields to CLUs is fairly high, but it's not the same from the 2008 usage of CLUs, fast forward through FSA's approach. When we get to 2019, that's the definition of FSA associated CLU we used for all of the tessellation, if you will, or a boundary system for fields and or CLUs. And then we had CDL data and other ways of looking and to see which the corresponding fields existed in. Within RMA's data, of course, you all know that the units of insurance are not just single fields and they rotate through time. So the simple matching of this across millions of cases through time is something that I don't think we should go back and try to recreate from scratch again. And you can learn a lot more at this level than if you have to use county aggregates or some other version where you have to rely on variation at a different level to create identifying effects. So we were able to do that. And if you roll forward, Rob will start on a couple of these, and Rob and I will kind of ping pong on this a little bit to make sure that we both have a version of the thoughts. And Rob's better at explaining things than I am anyhow. But one of the things that is important is that we don't have from a survey format an easy way to clearly identify where cover crops actually were effectively used. We can say some things about cost shared intent. We can say some things about reported. FSA offices, though, have different mechanisms for gathering data and have a different, relative focus on such kinds of data. So there's not just a simple way to do it, but more importantly, it's easier to look at what happened than it is to ask people what they think they did or plan to do. So we do think that we should come up with a more effective method for getting actual land use details. Some remote sensing approaches make a lot of sense. No-till is not, of course, a 0-1 thing either. There's versions of reduced till and degree of tillage, and how you count fall anhydrous application, for example, as tillage or not. We need a better, more precise mechanism for doing that. And it probably doesn't make sense to use expensive after-the-fact survey systems that have less correspondence to the effectiveness than we might be able to observe at a lower cost through other ways. The second thing, and this theme is repeated, but it's repeated in a couple of subtly different ways, is that the geographic unit of a field or a CLU or a land base that had one particular set of homogeneous activities, corn, soybeans, wheat, is pretty simple to do, we believe. There are a lot of cases, in particular in the kind of private side of the world, that have already done that for convenience in approaching other problems. So some mechanism for coming up with a standardization of the geographic mapping system. Lots of different words here. I'm trying to be as generic as I can, but if you think about putting together a jigsaw puzzle, always having everybody know what the shape of those puzzles were and where each of those was. So I know that, this particular field, in fact, was a field. So, and again, being able to do that across USDA agencies is a recommendation to USDA, but more broadly compatible with modern approaches for doing that. It's no longer quite the magic that it used to be. 10, 15 years ago, when I saw somebody put these together, it represented a whole lot more computational time. and complexity, and now it's kind of entry stakes. So next recommendations. And again, Rob, you have a good way of talking about this too, but we discovered that having a year, for example, as a timestamp is not very precise. When planting dates occurred, we have sometimes the planting date, but yields sometimes are associated with the next year's, we call them pancakes, the next layer of data that come in after the fact. And Rob, you want to talk a little bit more about just the difficulty in associating time with what we read in the data with what actually happened?
Sure. Thanks, Bruce. So if you think about how USDA data comes in, many of you see the various crop reports come out. And so one part of USDA may be collecting what are the planting intentions, how many acres of corn do we expect to have in Iowa? Then later we'll get a collection of data on how many acres were actually planted, but that could differ from how many acres are harvested because of weather and other factors. And later, still, we'll get data on how many crop insurance claims were paid out and so on. So there's multiple time points that data is being collected related to a given field or farm. And the challenge is putting that all together. And we found, for example, we had hoped to look at yield data closely in this project for 2019, but we found the 2019 time-stamped data we received was actually for 2018 yield data. So that's just one example of the challenges, and no criticism of anybody at USDA. These are just challenges when data is coming in at multiple time points being referred to in different ways. So
right, just that, Rob, if I can just interject, that's kind of on me, because me saying I'd like the 2019 yield data, which is what I meant. 2019 yield data happened to be reported in the period of 2020. And so it was a failure to be precise on the definition of the request on my part, which seems, rather simple to say 2019 data, but 2019 data set wouldn't be expected to include the 2019 yield data. So it's just that system of getting enough through time and continuity in the data system. One of our recommendations will be to keep this going. I mean, it was a pilot. We learned a lot. We built some complex things. It's time to take advantage of those. But as we roll forward, that particular problem will have a solution, but we'll need to still create a standardization of the difference between when something happened and when something was reported.
Yeah, our fourth recommendation was on weather. Obviously, this was all about a year with unusual weather, but we know that there's some great public data sources on weather, some of them generated by the private sector, some through existing other agencies that are pulling that weather data together. And just again, matching it all up is where the challenge comes in, because of course the weather data is not reported on a field by field or farm by farm basis. So figuring out the ways to layer this data together is one of those challenges we know the USDA staff are very interested in working towards. We're not saying anything that's a surprise to folks at USDA, and I do want to emphasize they're doing a commendable effort with not only the limited resources they have, but in some cases, they're working under past practices that may not be as relevant today, but it takes time to change and update things. So the last couple of recommendations were, first of all, going back to this common land unit area. Again, staff at USDA recognize there's a challenge there, but trying to figure out a little more robust way to have a geographic identification system for each land unit. And that should make it more feasible to lay together data from both different agencies and match it up to private sector information. And again, we know that this is a goal everybody shares, but just one that we wanted to reemphasize. And then the sixth one, just kind of looking at future projects of this type, we feel there's an opportunity for USDA to look at developing a process that researchers, whether they're coming from a university, maybe another government agency, can access a broader cross-section of this data. As Bill Northey said, the first and foremost consideration is the data be handled in a way that protects privacy, but we think this pilot project showed that that can readily be done without endangering any privacy considerations. And so we're hoping that there can be a process where there's some standard data formats that are accessible to external groups. And in the end, that should help us make better use of this data in a way that will benefit all of us together. So just to summarize, I'll provide a few summary points and Bruce can provide any final comments, is that as we said earlier, there were a couple of key data findings. One was on what happened with these prevent plant insurance claims. Basically, there's a positive story there with cover crops and no-till, that there was some reduction in the number of claims following the use of those conservation practices. Secondly, as we showed, there was data to show that when you are looking at the critical time period of yield, like as you get into June, that after cover crops and no-till, farmers were able to plant a little earlier, getting into that late portion of the planting window. The next point here is one that Dr. Sherrick identified, give him all the credit for this, is looking at the different types of soil productivity across the 6-state region. It was quite interesting that the fields that had lower productivity, you might think of a field with thinner topsoil, or maybe it's a sloping field that's had a lot of erosion. Those fields were more likely, not surprisingly, to be put into cover crops and no-till to protect that more fragile or soil or most sloping soil. But we were still seeing the benefits despite the fact that these cover crops and no-till were on poorer soils. So the fact that there's a positive response there makes an interesting story in itself. And then finally, the improvements in data approaches that we just talked about with the recommendations, we feel can provide further insights on how conservation practices and other management can affect crop risk. And that, of course, will help with future federal policy decisions, and perhaps most importantly, help farmers with achieving improving profitability. So Bruce, any final comments from you?
No, I think that, thank you, Rob. That's, as I said, I learn something every time I hear you explain the results as well. I think this has been, it's been an incredibly data complex project. It's kind of laid the groundwork for extensions to the project, in my opinion, in a way that are much lower cost now. And it has extensions that if we were going back and writing the original questions again, we would modify. We can now attack some other issues that perhaps didn't seem nearly as feasible when we started, and some of the questions that seem obvious aren't. The real question in my mind about getting a more comprehensive and a longer, in a sense, a longer data set lead to our ability to look in a single location at the effects under different weather conditions instead of only relying on the cross-sectional weather pressure, which we can do quite a bit with. I mean, it's a incredibly extensive data set, so it's not that all is lost in that case, but continuing to move this forward, continuing to help USDA with their data kind of organization and processing in a meaningful way is kind of the outcome of this project that I think we all have, gotten behind and are in agreement that needs to continue to go forward.
Okay, Deb, back to you.
Great, thank you very much. Okay, now before we open it up to audience questions, I actually want to ask Bill Northey a question, and it actually was asked in the chat. It says, is this webinar for producers? It sounds more like something for USDA or NRCS employees. Well, it is for producers ultimately, and I'm going to ask Bill, how do you see this work helping producers going forward? I know Bruce and Rob have commented on it, but you as a producer, a leader in food and ag, please comment on that.
Yeah, I think certainly the most important value is for producers to be able to understand what's the impact of growing cover crops and no-till, and I would love for us to have that next stage, having a matching yield with the actual experience of knowing what was on the ground, so that we could have the yield impact. But just the suggestion that you're less likely to have a prevent plant claim if you're running no-till and cover crops, 24%, that's a good size number, even though there's an awful lot of producers that say I'll never have one of those anyway. It still is worth thinking about what that is doing to improve the soil. I would argue an individual's experience is captured within their crop insurance history. So therefore, if a producer is getting better yields and or missing losses, they are seeing some benefits on their own and their own individual rating versus others that are showing some losses. So we may not quite realize it, but if we're seeing some better yields because of those things we're doing, whether it's the type of seed we're using or the fertilizer rate or no-till and cover crop, we should be gaining some experience that will actually help our rating within crop insurance. So one of those questions is, do we need to put a thumb on the scale and say, those folks that are doing some of these things, should they get better rates? I think they are over time, but it's slow and it probably isn't very obvious. But I would love to have that yield side. I think that's going to drive even more producers to be able to understand what the benefits might be of cover crop and no-till.
Great, thank you, Bill. And now turning to the audience, there is a question that's come in about how have you evaluated these results and how would you internalize them with respect to crop insurance premium methodologies, which is what Bill just discussed, Bruce, since you are a national expert on this, findings from this work.
So Bill started with one of the essential elements of crop insurance, and that is your own APH, and more particularly your trend adjusted, and in some cases, other augmentations to your APH provides one of the elements in the rating system. Pardon me for my voice today. It's not the only element in the rating system, and the entire system is designed to have a particular target for its loss ratios through time. Some of the elements that we've discovered are fairly easy to potentially implement in crop insurance rating. Field characteristics, topographical, topological, we don't include whether it's tiled or not yet. We have other elements that are, fairly obviously related to the risk of production outcomes, yet aren't incorporated in rating yet. I'm not suggesting that there's a simple thing you don't get, it doesn't work to say, put another set of parentheses around it and multiply it by 0.9. That's not where we're after at all. It's a much more comprehensive evaluation. Soybean producers would observe that their yield variation through time, for example, has shrunk. Corn producers have recognized that the place you can grow corn has changed through time. So I think that the system of evaluating how to provide crop insurance, which I'm a gigantic supporter of, proponent of, and believe it's been one of the greatest. Historically, the reason that crop insurance includes to avoid other less efficiently distributed ad hoc payments, and it's done a wonderful job. 2012 comes to mind, where we didn't even have an ad hoc disaster bill introduced, as far as I'm aware. And after 2012, bringing one other anecdote back into the comment, what we discovered is that despite what the public narrative might have been, trends actually went up as a result of the 2012 drought, because corn performance itself was better than would have been predicted given models up to 2012. And so one of the things crop insurance now reflects is that trend. And so those kinds of adjustments through time that are systemic, importantly investigated, defended, and understood, can become part of the rating system, in addition to the on-farm single case, which, as Bill said, it does become part of your adjustment. It's not, if you've looked at the formula for the premium for, say, RP, you'll discover that it's an insanely complex set of through time adjusted, calibrated measures to reflect the fact that it used to be 65 only, used to be price only, and we've added so many modifications. So we've had our eye on the prize forever, and we're moving in that direction. And I think it does require more work. I think it's important to do so carefully and with good peer review. The reason FCIC does what they do is because it does subject the proposals to a very high standard, and they're very expensive to develop, very expensive for AIPs to implement, so they shouldn't be taken lightly. So 12 billion or so plus premium per year, 120 billion more when prices are high liability program. We shouldn't just do those in some arbitrary or ad hoc manner. But this is part of the process of understanding how to represent risk in an accurate and fair way, equitably, at the level that it actually matters, reflecting the modern realities. We now have field level observations of things that we didn't have 10 years ago. So to ignore that would also be a different kind of error.
Yeah. Great. Another question that has come in. Could you provide an explanation for producers of the reduction in 24% odds ratio for prevent plant claims? Also, did the missing cover crop data affect your confidence in this result, or was it the amount, or was the amount of missing data relatively minor?
I'll take
Great
the first
question.
crack, Bruce, and then you can add in. So let me start with the cover crop data because that's the easiest part. We found that because there was not a lot of data from NRCS or Farm Service Agency on the cover crops out there, that we ended up in the end using satellite image analysis. It was data provided through Indigo Ag to have a much larger set of fields that we had a high degree of confidence were cover crop fields to do the analysis with. So that was how we dealt with the fact there were some gaps in the USDA data on the crop or the cover crops. The percent odds, as I've heard Bruce explain this, and he can add to it. So if you think of that 6-state area, let's just say, I'm going to pick very round numbers, that's roughly 100 million acres of row crops in those 6 states. And in that year, there were about 10 million acres that were declared prevent plant. So rather than saying, okay, the prevented plant acres, of which only part were cover crop and no-till, had a certain number of raw acres, what we looked at was the percent of those cover crop and no-till acres that impacted the reduction in prevent plant claims. So if you had, if you went from 10% claims to 7.6% claims or something around there, then you'd have that 24% reduction. But Bruce, what would you add to that?
I think it's a great question, and we've been round and round on how to explain it. Because of the method of estimation we had to use, and these are inherently probabilistic terms, there are some difficulties in how you would like to explain it. And Rob gave a great, I'll try to build on Rob's example. If you had a coin flip, you would say the odds are 50-50. And so the odds ratio is essentially one of the positive and negative outcome. If you reduce from 50 to 40, that's a 20% reduction in one of them, or a 10% reduction in odds, or it's a massive flip in the 1-to-1. So there's no standard common format. And because 2019 had a very high relative starting percentage of losses, I would say going from 35% down 3.5% is 10% of the loss. But if you went from 7%, which is about the fraction of acres in the most deeply affected areas, down to 3.5%, that's a 50% loss. So it turns out that you can summarize from these linearized probability models. And again, I apologize for the jargon. I see there's some technical researchers on the attendee list as well. You have to come up with a standardized way of saying how much did you reduce it. And so we're looking, if we were to go to a particular area, if somebody said, give us this county, what were the odds with cover crop? What would the odds have been without cover crop? We can run backwards the model in that location, controlling for the slope and the convergence index and so on, and come with an actual answer in that place. But absent me saying it's a X% reduction for these soils with this slope in this area with this amount of weather, given the history of crop, the best we could come up with is to say across all cases, the relative fraction of claims to non-claims was reduced by 24%. It's a logs odds ratio, sounds technical, but it's not. The bigger that reduction, the better. The smaller that number, the less important it is.
Yes, okay. I want to know, do you have confidence in this result? I'm just going to emphasize that again with what you just said. Do we have confidence in this result?
I'll start and I'll be uncharacteristically short. I have more confidence in these results than any I've ever seen before, because we have more and better data than any I've ever seen before.
That's great. Yeah, it was a seminal report in terms of the amount of information data that you got, the two of you analyzed, you particularly, Bruce. Okay, now I am getting another question about how long-term use of cover crops and no-till affect risk versus only having practices for 1 a year. There's a question about whether farmers should receive incentives for planting cover crops before they make a preventive plant claim. That's interesting. Okay. So.
Yeah, well, one challenge with the data, we would have ideally liked to been able to separate out fields that had, say, 3 or 5 years of continuous cover crop and no-till use, and that was pretty hard to do in the data. So in the end, we had to kind of revert back to just saying we had at least 1 year of cover cropping in a 3-year period we were looking at. We felt in most cases, those fields that were no-till throughout that period, although we know that there are farmers that do rotational no-till where they may not till in front of one crop in the rotation, but they do some light tillage in another part of the rotation. So that makes it a little challenging to look at the multi-year impact, but it would be nice for future studies to look at that more closely.
Yeah, Bruce, do you want to add to that?
No, I think that's a great answer. We have indicators, as Rob said, but the definitiveness of some of those was difficult without going beyond the data we received. We could look in the CDL and some other satellite imagery, but as you know, farmers, again, are the best at managing, and the switch from traditional tillage to no-till is quite often a massive implement investment. Planter difference, just differences. And so they tend to have a directional switch that isn't undone as much as it's moving from one tillage system to another is a pretty fixed decision. As Rob said, there are some like rotational tillage effects, and then there's some fall effects literally from anhydrous that become difficult to identify in the data because it has the effect of minor tillage to some degree. So all of that is part of the question. So I think accurately representing the farmer's actual behavior is what's critical here. And this is at least a big step forward toward that.
Great. Thank you, Bruce. Okay, we're moving to the top of the hour. I'd like to wrap up now. Rob, I would like to hear from you about next steps and your thoughts about the future.
Well, the report is being released today through the Meridian website. It's a detailed report that goes into the methodology at length. So I encourage people to take a look at the Meridian website for that full report. Next step is that we will be working on a couple journal articles to go deeper into the methodology and the results, including what was observed with some yields from 2018, that yield data set that was from an earlier year. We had some interesting findings. So those are a couple next steps. We also hope that USDA may look at taking this type of approach with some follow-up projects.
Great. And Bruce, you got 1 minute.
I think the experience we had for organizing, controlling for, augmenting, cleaning, assigning data into categories is just work that shouldn't be lost. And I hope there are ways of continuing to go forward with that.
Yeah, great. And Bill?
Well, I sure appreciate the work by Bruce and Rob and their teams. And I would say I was not super confident that there could actually be results found because there are a lot of holes in that data. But being able to use remote sensing to be able to figure out where cover crops are huge. And then somehow to navigate this different levels of CLUs. We tried to address that too. It's really a challenge. It's going to be a challenge for USDA to do that, but it sure be nice to go in and have the same CLU at crop insurance and NRCS and FSA, not just for data management, but for USDA's computer systems too. But if you're going to change to one method, you've got to readjust everybody's, including how many acres are in a farm and all those kinds of things. And those just became too big for us to be able to at least accomplish in the amount of time that we were there. So hopefully somebody else will get that done.
Well, we can help with our ability to do this kind of research. Listen, we're going to wrap now. I want to thank you for joining us today. You'll be getting an email with a recording and a link to the report. So please check our website. And thank you all in the audience who joined and for all the good questions. And our researchers are available to respond to anything you might have to ask them. So with that, I wish you and bid you a good day and thank you.